Hello and welcome back to the first ever Industry Tech Days presented by All About Circuits. I'm Dave Finch, host of Moore's Lobby, the podcast by engineers for engineers. Today is Thursday, September 3rd, and we are on the back nine of this fantastic week of live online events and relationship building. And I have to say, these events have been really well attended. For me, some of the highlights have been, the discussion with PI on gallium nitride. DigiKey had a session on wearable patient monitoring designs. That was cool. And of course, my old friend Alfredo Arno from ST Microelectronics giving us a great conversation on power density with silicon carbide devices. And of course, I've been having immensely enjoyable conversations with our keynote speakers, including our guest for today, Dev Singh. Dev is head of autonomous robotics, drones, and intelligent machines at Qualcomm, and he joins us this morning to discuss three technologies that are key to overcoming the challenges of autonomous robotics. Dev, thank you so much for joining me.
Thank you for having me over, Dave.
Yeah, so, you've held a number of positions with some semiconductor giants over the years, earlier at TI and now at Qualcomm. What was going on at Qualcomm that inspired you to make that move?
So, thank you again for having me over. I started off, I'm a double E at my heart. I have my bachelor's in double E, master's in double E. And I was a circuits engineer or a process engineer making silicon devices in TI. Did my gig in the factories, the foundries, and the back end. Making wafers, processing wafers, I had a very good opportunity to see the end-to-end flow of circuit design and making of a circuit or making of IC devices, particularly at Qualcomm. What I wanted to get was this thing beyond the silicon, is the software kind of things where you have the operating system that goes with the software. So at TI, we did a lot of analog digital devices, ASIC devices. At Qualcomm, there's more complexity in terms of the processors, along with the Android, the Windows, and the software that needs to go on top of this operating system, these great processors.
Right. Yeah, that it's funny you mentioned that as you start to go up that stack, your purview starts to expand so much. And so
exactly,
it's really important that you have that double E foundation and sort of that perspective on, where the chips are even coming from.
True, that has helped me tremendously along the way. And again, like I mentioned, I've been a bit fortunate to have this kind of exposure I had is all the way from the making of the chip in the back end in the factories to the design to the entire cycle upfront. So they call it back end and front end of the silicon manufacturing life cycle.
Right. Actually, hang on. I've got I keep this on my desk right by my mixing console. I've got a wafer. A wafer. I'm
4-inch wafer.
It is, exactly. I forget where it's from, but I'm the only person in my family who thinks it's cool, except for maybe my brother. So, but it's really important to have that foundation, and now you're involved in developments towards robot autonomy, which is what we're talking about today. So, where does autonomous robotics fit within Qualcomm? And then where does Qualcomm fit within autonomous robotics?
That's a very good, interesting question. And I'll give you a little bit of background on that. So when I joined Qualcomm, Qualcomm was at least 6-8 years ago, only focused mostly on the mobile devices. Of course, everybody knows Qualcomm as quality communications, and Snapdragon processor is at the heart of every smartphone device, including the modem and all of the technology. But consciously, through a couple of years after I joined Qualcomm, Qualcomm did want to diversify the portfolio a little bit because, yes, mobile is saturating. And then there are areas like automotive and IoT coming up. So there was a good initiative within Qualcomm to have this diversified or adjacent business units, you would call them. So we have automotive business unit, we have an IoT business unit, and IoT is a very ambitious term. It's catch-all phrase. If it's not a phone, if it's not a car, everything else is IoT. Everything else
Right.
like um, XR, VR to smart Alexas to the smart thermostats, everything falls under the IoT bucket, whichever is connected to the internet has the processing power, and then so we were looking for segments that had very good fit for Qualcomm. That means you can use your existing Qualcomm technologies, and also the market is very attractive. So we were looking for those kind of businesses overall, and I did the business case for robotics, and I convinced the management that hey, robotics is the area that need all the kind of processing that we have, and also it's a very attractive market. It's coming up in a very nice way in a lot of segments. And again, robotics also is a very diverse field. So that's how, in around 2016, 2017, I did the business case for the product line or for the business for robotics, and we initiated the business then. And now, fast forward 3, 4 years now, and we've been immensely successful at it. We have all kind of stuff in terms of robotics, which includes robots, drones, and intelligent machines, everything from home robots to industry factory robots and everything in between. And of course, autonomous robots, the term autonomous means, of course, you want robots to be doing things by themselves. That's when they become more efficient and more attractive because they are taking over some of the functions that are redundant and few other things. So autonomous robots is the thing that we drive with our processing.
Right. And so this was before you introduced this at Qualcomm. This was not something that was necessarily on the standard product roadmap or part of the standard portfolio. Is that right?
That's correct.
Well, congratulations. That's huge. I mean, to introduce it.
Thank you.
I want to make sure that our listeners understand how rare and massive it is to essentially establish an entire revenue generating business unit within a very established company already that was doing just fine and is now doing better because you've introduced this. That's incredible. We should do a whole second session on that, but I'm going to try to stick to the topic at hand.
Would love to.
I'm going to have you autograph my wafer. But getting back to robotics, to set the stage a little bit in the simplest terms, we all know what robotics is. To you, what would constitute an autonomous robot?
So autonomous robots. So the word autonomy means which has complete freedom and is not controlled by external forces. So you're doing everything within or autonomously, right? That's the word autonomy. So in terms of robot, a robot is able to sense, think, act, and communicate. That is what a robot does. And if it is doing all of it by itself, so uh, you're having enough sensors to perceive and understand the environment that you're in, and you're able to process that and think through, okay, that's an obstacle or that's the path, and be able to act or take a decisive action and then communicate back. And that's the loop that the robot does: sense, think, act, and communicate. That's what an autonomous robot does. And it does this around 30 to 100 times within a second. Every second it keeps doing this. And that's what humans do as well. We have eyes to sense and ears and smell. We are sensing our atmosphere or our environment. And then we are making decisions, what we need to do. And that's how we are act autonomously, and that's the concept that the robots also are following, and that's how they're evolving.
Yep. And as we look at this evolution, these autonomous robots versus, say, the traditional robotics that we find in, say, factories and even automated factories. These are still machines that are not totally aware of their surroundings. They, they have to be controlled, that sort of thing. So when we're talking about autonomous robotics, where do you see these being used and how?
Everywhere. Just to give you a little bit of example, of course, the industry and factory robots have, I won't call them dumb robots going to smart robots or becoming intelligent, but it's just an evolution. Of course, and it's an evolution of things. A basic example which people will be able to relate to is take a vacuum cleaner, take a Roomba, for example. 10 years back, Roombas existed. They were robots, but they are more of uh, they would they had more mechanical functions in terms of moving around, trying to clean your apartment or your room. And then they would have a bumper based sensor where they would bump into a wall and then bump back. And of course, it would be a random bumping around trying to clean the floor. Now, fast forward, now you have a camera on the robot, on the Roombas, where it is doing a function like VSLAM, which is visual simultaneous location and mapping. While it's moving around, it is simultaneously visually locating itself, mapping the room, but at the same time being able to position itself with respect to the wall and the other wall. So it's able to do its mission in a planned way and then stop because it's out of battery, go back, charge itself, and then it knows that where it stopped. So comes back and resumes the mission. So again, that is a level of autonomy. So you will see autonomous robots come into people being introduced into our lives in different facets of things. Of course, I talked about home robots. Then you're talking about intelligent drones and delivery robots, enterprise robots in the hospitals, in shopping malls. You would be seeing more and more of these robots as service robots being introduced. Then, if you go to Walmart, you would now see a robot autonomously cleaning the floor, and there'll be a robot that will be going around the aisles of Walmart or Target, trying to get a good sense of the inventory, scanning the shelves, making sure products are in place, the pricing labels are correctly put or not. So there's a lot of things that robots will be doing, and we'll be seeing them being introduced in our daily life. And the industry, the factory is a whole different gamut. If you go to a Tesla factory, all robots. Robots are on assembly lines and they are doing a lot of things. Again, they are also evolving from just being robots doing their things, more mechanical, more single function, to being more autonomous over time.
Right, right, and so plotting that along, at every step or sort of milestone of that evolution, we introduce new challenges to the design engineer. And so from the perspective of a design engineer in getting us to that level of autonomy, what are some of the more recent unique challenges attendant with autonomous robotics?
So autonomous robots and artificial intelligence are synonymous or go hand in hand. So basically, if somebody talked to you 10 years ago or 15 or 20, 35 years ago, and somebody said artificial intelligence, something that would come to your mind would be a robot, right? It would be a robot that was poster child for artificial intelligence, because it's a human, and a clone of human is a robot, which is artificially intelligent as a human, right? So now artificial intelligence is associated with everything. Of course, that is what artificial intelligence is. But going back, one of the key component of autonomy is intelligence, being able to consistently perceive the environment, being able to understand uh, where I am, what am I doing, what is my next step, being able to uh, learn over time from the mistakes. A Roomba gets stuck under a sofa, it knows, oh, next time I don't want to go there, kind of thing. So it
Right.
understands what it needs to do. So learning over time. So intelligence is key. So one of the things is reliable intelligence, right? So reliable intelligence on the edge. So electrical engineers will have to plan about that, saying, okay, you can bring intelligence to it, but it needs to be reliable. At the same time, it's on the edge. So it cannot be a server class intelligence. You need to have it more power efficient.
Yeah.
You need to have it be able to do multifunctions, but you need to consider the power and thermal elements of things. There's a balance of the AI workloads versus battery operated devices, and things like privacy, security, and then safety again is a very important thing as well. As you see these autonomous robots come in 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 our lives, and also in manufacturing floors become collaborative robots, work with human beings. They need to be safe as well. They need to be able to understand when to stop functioning in a graceful way as well, right? You cannot be holding a 100-pound thing and then drop it just because you're out of power. So you need to be able
Right.
to do a functional safety and operational safety kind of things as well. So there are multiple things like I've talked about is a reliable AI, making sure power and thermal efficiency, making sure security and privacy, and making sure the right workloads are chosen for a robot to be intelligent, but at the same time be efficient.
Exactly. And so this makes perfect sense to me now. So that now we've got to be aware of our surroundings. We've got to be intelligent, and we also know that breaking these sort of disciplines or technical requirements into their own separate categories. Maybe we call those categories 5G for communication, because we need to be able to communicate, just like our own brains do, a tremendous amount of information as the information is being processed and understood and then acted upon. So that leads to things like also obviously artificial intelligence, but also something that we're talking about this morning, which is going to be heterogeneous computing. So these three sort of categories can all be leveraged to address these sorts of challenges. So what do engineers need to understand about these three different enablers? Designing with them, what's available to them, that sort of thing.
Great. And nicely put. So going back when we talked about robots sensing, thinking, acting, and communicating, so you need a lot of sensors. You need the AI element of things. That's where the heterogeneous compute comes in, where you need different kind of things. So you need camera processing, you need sensor processing, but at the same time, you need the brain. And then the acting also needs to be able to make decision. And the communication part is where cellular connectivity, Wi-Fi, and 5G comes in place. So putting all of this together in this era of AI, 5G, and heterogeneous compute, you need to be able to have the right workloads, which is the heterogeneous compute. You need to have CPU, GPU, DSP, all kind of workloads in the robot. But at the same time, when you're processing this information, you need to be able to, you need a lot of intelligence at the edge. But because there are challenges on the edge where you have to balance out the intelligence that you can put on the edge versus the thermal efficiency, the power efficiency, the form factor, and of course the privacy and all of that stuff, you have to keep them in mind. But now you have a concept of distributed learning, right? Where you can have enough intelligence on edge to do what you need to do, but then there will be a time for the edge cloud and there will be a time for the central cloud. And the 5G technology, like 5G, is going to be the link where it will make this seamless. You will make sure you have enough intelligence on the edge to make proper decisions and be able to navigate, understand the environment. But at the same time, you are in a complex situation and you need more workload. You have 5G for your brain to be extended to a edge cloud or a central cloud where you can get more information and tap into the bigger brain and be able to get that. Why 5G is very important is because of the latency. 5G comes in with tremendous throughput and latency. So you are able to make these decisions, but at the same time within split seconds. And that's what is very important for a factory kind of robot situations where your robots in this mission critical stuff activities where you're doing a lot of things. And at the same time, you need a sudden burst of information. You have 5G as a pipe that will be able to get you what you need in terms of learning. And then also comes concept of federated learning when you have these robots that are operating in swarms, and these robots are a family of robots. Robots are learning from each other because one robot is in an environment where it's sensing its environment. The other robot has never seen that environment before, but say it needs to be deployed in the same area or be replaced. Now your brain is being transferred over because you have a concept of federated learning where the robots are understanding their environments, they're getting it to the central cloud, and the whole thing is being aggregated, and you're learning more and more and more. That's a concept of federated learning as well.
I love this. The comedian in me is thinking my wife would love nothing more than to be able to take everything she knows and just 5G it over to me so that I don't have to take so long to catch up. Same with every boss that I've ever worked for. But but the communication piece is really, really fascinating to me right now because, like you said, we have sort of, if you've got an entire group that can accelerate their learning that much faster. The bottleneck before surely would have been, among other things, but the big bottleneck would have been the communication because we just haven't had the bandwidth and the reliability and the speed to transfer that much information reliably to to so many different recipients.
That's true. So 5G comes with this thing called URLLC, ultra reliable low latency communication, which is very important. Is not only you want low latency, but because these are mission critical stuff where you have factory environment, you need high reliability. So 5G comes with something called 5 nines reliability, 99.999% reliability. So that is the 5G.
With that reliable sort of communication infrastructure available, and by the way, this is why Qualcomm is such a great and natural fit in the space of autonomous robotics, is because you've obviously been developing these sort of connectivity architectures. That's really the sweet spot of a lot of what Qualcomm does. So where do you see the most headway being made with these three different sort of categories?
In a lot of fields of autonomous driving, XR, VR, there's lot of areas that technology that's being developed in Qualcomm is put into good use. The If I can bucket these to like the compute, the heterogeneous compute, the AI, the 5G technologies, all of these technologies are being put in good use in lot of areas. And robotics is one of those beneficiaries and one of those areas that is utilizing them. I mean, just yesterday, there's Amazon has now FAA approval to use drones for deliveries. And if you imagine drones a few years ago, you would have remote controlled operated drones. But now you're talking about drones that make deliveries. So these are all going to be cellular operated drones. They're fully autonomous drones that will take off from an area, go to a designated area and drop off the package. And it's going to do this fully autonomously beyond visual line of sight. We call that BB loss. And how is this going to happen? It's going to happen over cellular. And now you need to be able to do this beyond visual line of sight. You need to be able to do it autonomously. You need this big aspect of reliability and latency as well. So 5G is going to be very, very helpful there as well. So there are a lot of areas that will use this kind of technology. That's the future.
Right. And of course, getting us to the future are the engineers who have the opportunity to work on this sort of early edge of things. So what sort of hardware tools and resources are available to engineers to start exploring these different technologies and solutions?
Yeah, I think this is one of those eras where I think this is the dream come true for engineers. I mean, few years ago, something like robotics was a hobbyist market. I mean, you would have to be interested in robotics, A, and then B is you would be trying to take off the shelf products to make a Frankenstein. I mean, just making it up, but
Yeah.
that was robotics. I mean, you had to pick your processors, you had to pick your sensors, you had to pick your right elements that you needed to be as part of the robot and be able to hook them up into the motors and the drivers and the propellers, whatnot, right? So that was the traditional robotics market, or a traditional DIY or hobbyist market, which is the maker community. And now, fast forward in this age of compute, AI, and 5G coming together and make being available for everybody out there, right? It's a dream come true. So, first of all, the challenges for robotics are in terms of picking the right workloads. Before, what would hobbyists do is pick the off-shelf GPUs or CPUs, but now you have these tremendous power efficient processors that have XYZ amount of tera operations of AI power at the edge with truly integrated camera processing, video processing, audio processing, all in a single board that's a credit card size board. So those are the things that now are accessible. I mean, one of the example would be the RB5 platform that we launched just in June this year. So it's it's available for engineers to take this and make a quick prototype out of. Not only that, the hardware is there, but now you have a lot of tools like the SDKs that go with it, where you can train your own models and implement your own AI models. Not only the AI models, but you can do the computer vision. You can do a quick SLAM, which is a simultaneous location and mapping, using the cameras, the sensor fusion that we already have, along with the SDK that comes with it. So OpenGL, OpenCV, those kind of SDKs are readily available. So this is a wonderful time to be an engineer, to be able to play around with the hardware and the software that goes along with it.
Absolutely. Like you said, it's so accessible. Even 20 years ago, 10 years ago, even the available landscape of development tools, development kits, just to do simple 32-bit, embedded applications, it was still kind of marginal. So it is. I agree. It's an awesome time to be an engineer because of what we have access to now, and because of the body of work that's accumulating across Qualcomm and the rest of the industry, in terms of, like you said, artificial intelligence, the wireless connectivity expertise, and then things like distributed computing, heterogeneous computing. So from where you're sitting right now in the industry, um, describe how it's going with essentially the convergence of these three sort of key technology pillars of heterogeneous computing, 5G, and artificial intelligence.
So all these are very, very powerful technologies. They 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 are, like you said, the tremendous amount of compute, which is heterogeneous compute, which is different different kind of compute. You have readily available compute, very power efficient compute on DSPs. You have GPUs, different kind of compute being able to be packed on a single SoC. And then AI is, of course, is changing people's lives. I mean, AI is changing people's lives. 5G and communication, from all the way from 1G to 5G, right? You've seen how the evolution of communication has happened when you were able to make phone calls. You were able to make phone calls and do texting at the same time. Now, then you were able to do watch videos, and now you're able to do a lot more stuff, right, with 5G. So they have individually changed human life and human experience. But the unisons of them is magical. I mean, when you get these powerful technologies together and they help each other improve. For example, if you take 5G and AI, so AI is going to make 5G better, and 5G is going to make AI better. And how is that happening? It's the concept of distributed learning as well, right? Where, of course, you need learning to happen in different nodes, and there will be challenges how much compute you can put on the edge and how much computing. And 5G is going to be the pipe between the edge, the device, and the central cloud as well. And that is where this whole loop of making each other strong is going to keep happening. And this is the unisons of technology that's going to take place. And that's one of the examples. And you'll be seeing this more and more when it comes to collaborative robotics, when it comes to remote surgeries, when it comes to warehouse operations, lights out manufacturing. So all these areas you will see the magic happen because these technologies work together.
Exactly. And working together to hopefully not only significantly reduce, but presumably could even eliminate altogether the chance of serious human error. Like you said, in robotic surgical applications, where the cost of human error is quite significant. Is the best doctor out there is not as good or capable as the collected wisdom of all the doctors out there. My arm's starting to feel a little bit cramped. I better tap out right now. A machine isn't going to be low on potassium that morning and won't make a little slip. So this has been tremendous. Before I jump into the Q&A, have you seen some just really successful examples of this convergence already, even though we're fairly early into this evolution?
Yes. So one of the areas that is in lead of being the right beneficiary for all of this technology is the Industry 4.0, which is we call it Industry 4.0, the fourth revolution of industrialization, where AI and 5G are the key elements. I mean, 5G is the underlying fabric of communication, and AI is where is the game-changing part as well. So we are already seeing the heterogeneous compute, the 5G and AI coming together in terms of making this Industry 4.0 happen, which is reconfigurable factories, where factories can be reconfigured on the fly, because most of these robots and machines are now not tethered down by wires, they're wireless. So you can reconfigure a factory line in a shift, which would take a 3 months downtime to reconfigure your factory to move from manufacturing model X to model Y or model A to model B. Now you can do that within a shift, because now you have a reconfigurable factory, because you have everything wirelessly done with 5G. And now you have a more lights out manufacturing, or warehouses where you have fulfillments going on because of this AI happening on the edge kind of stuff. So that is the area that we'll be seeing the immediate beneficiary. And then, of course, there's a lot of other areas like I talked about warehouse and deliveries, first mile delivery, last mile delivery. Those are areas will be taking a very, very good advantage of this thing to tremendously improve the efficiency and human lives.
Absolutely. Enough preaching from me. I can see that our audience has been loving this conversation. So, and we've already received a few questions from the Q&A tool. And by the way, if you are with us live and you have any questions for Dev Singh, please drop them into your Q&A widget there. It's right on your screen in front of you. So let's field a few of these that we already have. Our first one is Harris. Hello, Harris. Harris is from Olathe, Kansas. He wants to know, what are some recommended practices for designing a heterogeneous architecture? Not necessarily, he says, not necessarily limited to robotics.
Yeah. So what is heterogeneous compute? You have to always come back to that, right? I mean, heterogeneous compute is when you need different kind of computing blocks. So there is different kind of compute available. You have the CPU that gives you tremendous power processing, which is very real time, but at the same time power hungry. Then you have GPUs that does a different kind of compute. You have multiple shaders and few other things. So it's very good for things like gaming, things like image correction, and few other things. So that's the GPU part of things. And then you have the DSP, which is another block of compute, which is very immediate, but at the same time very power efficient. So choosing the right compute is important. So now when you have a heterogeneous compute block, it's like you have a Swiss knife. So you know your application. Okay, you want to cut an apple, open the knife, and you want to open a bottle, then take the bottle opener kind of thing. So now you get the choice of heterogeneous compute. That is what the power of heterogeneous compute is, giving you the right Swiss knife or a Swiss army application you could use for any kind of application. This could apply to robotics. This could apply to XR, VR, for example. This could apply for any kind of operation where you need always on function, and you want a robot or an entity to be listening to you always on. So you want to run that on DSP because DSP is very power efficient. And when it listens to a wake word, then it wakes up the rest of the system. That's the beauty about it. Well, whereas if you had been doing this on the CPU, it would be burning power. But now you're doing this compute on the DSP, and it's always on, but it's low power, and then it keeps the rest of the system in sleep and it wakes it up. So it is just one example of it. So you could apply this heterogeneous compute in any application, and you could use the right efficiency of the right block for what you need.
Exactly. The building block model, so to speak. And then, of course, as you just mentioned, every 6 months, probably every 12 months, you see an appreciable improvement in each of these building blocks, and they just keep better and better, keep getting better and better. Okay, so Swapnil is in beautiful Denver, Colorado over here in my neck of the woods. Swapnil writes, well, he says, Dev, hi, and thank you. So hello from Swapnil. I'm interested to know about Qualcomm's AI resources. So I'm just going to put words in his mouth and presume that he's referring to Qualcomm's software tools, chip architectures, that sort of thing.
Yeah, I can elaborate on that a little bit. Yes, so we have been doing a lot of innovation in AI. I mean, we're known for our 5G technology, the mobile technology, but we have been doing a lot of R&D for years now. We have a lot of not only that AI is put into our newer and greatest processors as part of the neural processing engine. I mean, we use different compute blocks. I mean, you can do AI on CPU, GPU, DSPs as well. But again, like we talked about the nature of heterogeneous compute, Qualcomm, we realized that you need a dedicated hardware accelerator for AI. So we have some similar to an NPU, neural processing engine. We have the AI, which we call AI engine. We have a dedicated block for that. It is DSP based. It is HVX DSP based block, and that's very important because you not only want tremendous inferencing, which is AI, but you want inferencing per second matrix is one of the vectors for measuring how efficient your AI is. But what we like to measure is, of course, you want to have inferences per second, but you want to also have inferences per watt. How much inferencing can you do per watt as well, right? I mean, you can't be burning uh, uh, or cooking eggs at the same time with the heated up SoC. So that's
Right.
very important. So we have the most power efficient AI block within the SoC. That's how that's the starting point. And on top of that, that's the hardware. And on top of it, we have software, which is we have a Snapdragon neural processing engine. We call it Snappy, SNPE. That is this SDK. It's a real-time SDK that helps you. It's a runtime SDK that helps you take any kind of models that you've trained on the cloud, implement in convert to .dlc. And what this tool does is it converts the models and autonomously or fully by itself converts these models and implements it in the right blocks. So what it does is takes your AI algorithm, it implements it has choice from CPU, GPU, DSP, and the AI block as well. So it decides which is the best block for it to put on. And then it at the same time, what it does, it gives you a comparison of report generates saying if you implement on the CPU, this is the inferencing you get, this is the power, this is what you consume. It recommends the best block to run your algorithm on, but at the same time, you can override it too and decide as well. So the it makes it so seamless and so easy for people to use. Is you have the right hardware block, and then you have the SDK that helps you convert the models and implement it on our block. So that's the entire suite of AI. Nothing is complete if you don't have the hardware and software together complete.
Exactly. The the parallel that I would draw there would be there were companies that made microcontrollers, and there were companies that made high side drivers and power MOSFETs and power devices for, say, motor applications. The companies that were very successful in winning motor control sockets were the ones who said, well, we've got all this hardware, let's build the software layer over it that sort of links it and gets the customer, the engineer, a certain percentage of the way down the road so that they can develop their application and not start from scratch building a foundation that already exists somewhere else. No, that's great. That's so I'm assuming, Swapnil, you could also visit the website and kind of play around and take advantage of these tools. So, okay, do you have time for one more, Dev?
Sure.
All right. This was an interesting one, quickly from Iris, who is in Singapore. Iris asks, 5G offers many benefits. However, maybe not everyone is building on 5G. Are other connectivity options also suitable for autonomous machine?
Absolutely. So yeah, 5G will be is already the underlying fabric for the Industry 4.0 kind of application. But not everywhere you need that kind of latency. So you have different. So if you're doing a surgical robot, the latency round trip delay is sub microsecond. But then if you're using an AGV that's carrying a pallet from one end of the factory floor to the other end of the factory floor, and it has the right sensors on it, and it's able to make a lot of decisions on the edge, sometimes Wi-Fi is good enough, and sometimes 4G or CBRS, if you're in a private network, CBRS, which is based off a 4G standard, is good enough as well. So yeah, I mean, what 5G brings in is the throughput and the reliability and the latency. So if you have any requirement which is below 20 millisecond round trip, you can't tolerate the delay, and if it's a mission critical stuff, that's when you need 5G. But if your requirement is 20 milliseconds and higher in a round trip latency, you can go with 4G and other technologies as well. So absolutely. And when you take a home robot, you would probably, it may be I'll say never say never, but probably it will be for a foreseeable future. I don't see Roombas being using 5G kind of thing, right? So they're going to use Wi-Fi, Bluetooth, and all of those technologies. They want to be connected. They are Internet of Things devices as well. But 5G will be an overkill in some certain application.
That makes sense. And especially when you get into mass production things where cost becomes a very sensitive topic. But no, thank you for explaining that. I had actually just placed all of my bets on 5G just because I know that even transferring data from one computer to an external hard drive tends to take a long time. So, especially when you start factoring in vision data, video processing, any kind of audio, that sort of thing. Well, this has been tremendous. What an enlightening conversation. Dev, thank you so much. That's the time we have for now. Yeah. I appreciate you making us all a lot more versed in autonomous robotics than we were about 45 minutes ago. This is great.
My pleasure.
Yeah. If folks, if you're watching this live, enjoy the rest of your day here on All About Circuits. We've got technical sessions and wide gap semiconductors, obviously autonomous robotics, power over Ethernet, single phase motor drive, MEMS, beam steering, so much more. And do remember to reach out and connect with other attendees throughout the day. It's all about building those relationships. So thanks again, Dev.
Thank you. Really appreciate your time. It was fun.
It was fun for me too. I'll have you sign my wafer. And everybody else, cool. Everybody else, have a great day of sessions, and we'll see you tomorrow.